Okay, guys, today's task is to learn how to write something like which is, let's say, there is 3 sine theta plus 4 cos theta, and we'll be writing that into this form, which is written here r sine theta plus minus alpha, or into this r cos theta plus minus alpha. I should tell you that why do we need to learn this? See, in your P1 trigonometry, you have been seeing such equations where you have, for example, you have 3 sine theta plus 4 cos theta, and that was equal to 0. So we solve this equation by dividing the whole equation by cos theta, both the sides by cos theta, and we end up with tan theta in our equation. The purpose is, as you know, okay, we should have one trigonometrical ratio throughout the equation. Since there was sine theta and cos theta, uh, the method to get rid of these two ratios and to have just one is we divide both the sides by cos theta. We can do this if there are just these two terms. There's one term in sine, another is cos, and you have the zero on the other side of the equation. But this happens here that instead of zero, we have a number. Let's say we have 2 over here. Now we cannot write this into one trigonometrical ratio by just dividing both the sides by cos theta. See what will happen here. If you divide this by cos theta, you see that this will become 3 tan theta plus 4, that is equal to 2 secant theta. We might have accepted this if there was a square on this tan, but now again there are two trigonometrical ratios, but we want just one of them. Therefore, there is totally altogether a new method to solve such equations where you have a number on the right hand side, and the left hand side has got one term in sine, the other term in cos. There are many other reasons as well for writing this single expression into something which is purely in terms of either sine or it is in terms of the cos. But we'll be only interested in solving such equations where we have two terms, but there is not a zero, there is a non-zero on the right hand side. We'll also be seeing how to find the maximum and minimum values of these expressions. Okay, so we'll be learning this new method mainly for two reasons. One, to be able to solve the equations where we have one term in sine, the other is cos, and there is a non-zero at the right hand side. And secondly, to find the maximum and the minimum values of such expressions. Okay, the method is written here that if you have a sine theta plus minus b cos theta, and how to write that equal to r and sine theta plus minus alpha. The method is written here. Your r is a square root of a square plus b square, and your alpha can be found through tan alpha, that is equal to b over a. But I'll give you the reason why do we have it this way. Okay, let me give you the reason, and then we'll be going towards the questions from the exercise. Okay, guys, uh, the thing is that we can have four kinds of operations. We look at these plus minus over here and plus minus over here. Okay, now let me write here. Let's say we can have 3 sine theta plus 4 cos theta. We can have 3 sine theta minus 4 cos theta. We can have 3 cos theta plus 4 sine theta. I'm using this 3 and 4. This can be any number over here, okay? We can have 3 cos theta minus 4 sine theta. If your first term is in this expression, if it starts with a sine, then you can write this in terms of sine. Okay, this is going to be r sine. If there is a plus between them, you will have a plus over here. If there is a minus between these, you will have a minus between them. If instead your first term is starting from the cos, so you will be able to write this in terms of cos. And if there is a plus, there is will be a minus between them. Okay, and this is going to be r cos theta plus alpha. So we can have four cases where we have to write these expressions into this form. Okay, I'll be just solving one of these four. Okay, now look at this. When you have this 3 sine theta plus 4 cos theta, that is r sine theta plus alpha. I'm just going to take this one. Okay. Um, yeah, I'll give you a method, explain the method, and that will work for all these four situations here. Okay, so let's see how to do that. Um, I need to copy this on this side so that I can use the space here. Okay, so let's say we have uh, 3 sine theta minus 4 cos theta. The method that is again a reminder, the method that I'm going to tell you, that is an explanation that why do we have that shorter method. The method I'm explaining right now will not be used to write these expression into these forms here. Okay, this is just a reason, a logic why do we do so. Okay, so this is 3 sine theta minus 4 cos theta. We'll be asked to write this in the form r sine theta minus alpha. Okay, I will expand the right hand side, and let me excuse for just putting the equal sign here. So you know that what is sine theta minus alpha? This is sine theta cos alpha, and then minus, oh, there should be theta. Then minus, you have sine alpha and cos theta. Let me expand this. This is 3 sine theta minus 4 cos theta. That is, I should use this identity mark here. This is r cos alpha. I'm intentionally writing it like this. You will find out why. Minus r sine alpha cos theta. Guys, if you have 3x plus by, that is same as ax plus 2y. Can you tell me what are the values of a and b here? What is your a and what is your b? Yes, anyone? If you have 3x plus by, that is equal to ax plus 2y. So what are these?
AS3, BS2.
A is, you just compare the coefficients of x and y, and you see that your a is going to be equal to 3, a is going to be 3, and your b is going to be 2. Similarly, if you compare the coefficients of, look at this, this is your sine theta over here, and this is your sine theta over here, and this one is your cos theta here, and this one is your cos theta over here. So if we compare the coefficients of sine theta and cos theta, see what do we have? We have r cos alpha, that is equal to 3, and we have r sine alpha, that is equal to 4. Don't worry about these minus signs between them. The minus is matched by the minus. Okay. Okay, so we have to get the values of r and alpha. If we square them side by side and then add, see what do we get? We have r square cos square alpha plus r square sine square alpha, that is equal to 3 square plus 4 square. You take r square common from here, you have cos square alpha plus sine square alpha. That is going to be, let me write this still as it is. I'm doing this purposefully. So this r square is going to be 3 square plus 4 square. Therefore, this r is going to be the square root of this 3 square plus 4 square. And at the end, I'm going to write this r is going to be 5 units here. Okay, look at this. You can see that why there this r is going to be under root a square plus b square. Okay. Secondly, um, if you divide these two equations side by side, let me keep this r sine alpha in the numerator. If you divide them side by side, you have r sine alpha over r cos alpha. That is equal to 4 over 3. R is cancelled by the r, okay? And you have been left with the tan alpha that is equal to 4 over 3. You can see that here it is your tan alpha that is going to be b over a, that is b over a. And yeah, we will find this through this tan inverse of this 4 over 3. I think that is going to be 53.13. I'm just doing that mentally. Okay, so this expression, which was um, 3 sine theta minus 4 cos theta, that has now become, this has now become, that is equal to 5 sine theta minus 53.13 degrees. Okay? Now, uh, just compare these two. Whenever you have to write these two terms into just one single term, you see that if this first one is starting with the sign, you will be writing this in terms of sign. I'm telling this again, okay? So that I can tell you what are these A and B. So if the first term is beginning with the sign here, and you have to write this in terms of sign, then don't worry, you can easily, comfortably say, okay, your A is going to be 3 and your B is going to be 4. Your A is 3 and your B is 4. You only need to apply this formula. You will say, okay, my R is going to be the square root of this A square and B square. You'll simply say this is 3 square plus 4 square, and that will be 5. And then you will say, okay, my alpha is going to be tan inverse of B over A, which is this 4 over this 3, okay? This is 4 over 3, and you will get to that alpha over here. ठीक है बच्चों, that is how you will be doing the same in all these four cases over here. ठीक है? In all of these four cases, I have intentionally taken this 3 and 4. So all these four situations, they all have A as 3, they have B equal to 4. All of them will have the same R, they will have the same alpha. ठीक है? Let's go to the exercise and try some questions from there. ठीक है? Let's go to the exercise. Okay, here is the exercise with me. So I'll do just one of these parts questions and then you will practice the rest yourself. Okay, I'll just be doing the first question. I always do the first question because these are easy and I keep the difficult questions for you people. You see how clever I am. Okay, so this is, I'll not be doing this 15 sine. It is the same I did. It is starting with the sine and you have to write this in terms of sine theta minus alpha. Let's see, yeah, let's do this second question here. The second one, okay. Now it says express this in this. You see, the first term is starting from the cos and is asking you to write this in terms of cos. And when you have the minus between these two terms, you remember there is a plus. This is going to be cos alpha plus beta kind of a thing. Okay? So remember, you have to follow these instructions. He says give the exact value of R and your alpha correct to 2 decimal places. And your alpha is in degrees over here. Okay, so you must have the calculator with you. I don't have this right now with me. So you will have to find the tan inverse of 3 over 2. So please be ready for that. Okay, so guys, we have 2 cos theta. We have 2 cos theta minus 3 sine theta. I'll quickly say, oh yes, my A is 2 and my B is 3. I will not say my B is minus 3. Never ever put this, include this minus over here. Okay, so now I'll get my R quickly. I know my R is going to be the square root of A square plus B square. I have to keep that in exact form. So 4 plus 9, that is going to be the square root of 13. And then I'll have my alpha, that is going to be tan inverse of B over A. So this alpha is going to be tan inverse.
56.3.
Oh, just a minute. That is 3 over 2. What is this, beta?
56.3.
It says correct to two decimal places. You
51.
3.31.
53 point.
56.31.
Thank you, beta. So please don't lose your marks because of these. I mean, ignoring these conditions here. So we have got this. The answer to the first part is going to be under root 13 cos theta plus 56 point. That is it. Okay. You have got it. And then it says, hence solve the equation, blah, blah, blah. So now we'll be solving this equation here. It is here. Um, okay. So this B part. It says, hence solve this equation. So instead of all of this, guys, instead of this, what should I write now? I'll simply write under root 13 cos. You see, that was the purpose of uh, learning this new method. That is equal to 1.3. See? ठीक है अच्छा so now when you have been given your theta as between 0 and 360 degrees, you see you have got a composite angle over here, so you have to handle this. ठीक है some people do that mentally, but if you are not that mentally that strong, so you can just assume, you can say let this theta plus 56.31 is equal to y. Don't put that equal to alpha because alpha has already been used here. Okay, so this becomes under root 13 cos y, that is equal to 1.3. And you must tell that what are the limits for this y over here. So your y is going to be between 56.31 and 416.31. Okay, so now let's solve this equation. This is cos y, that is equal to 1.3 over under root 13. So you have this cos positive. So we know that this is going to be in these two quadrants. Now, please tell me quickly what is cos inverse of 1.3 over under root 13? Yes,
68.8657.
68.87. Okay,
65.
okay, 68.87. Okay, guys, can I keep this my first value of y? Hmm?
Yes.
Yes. Oh, yes. Because
Yes.
yes, it is in this range. Yes, very. I was thinking we can. Okay. So this is 68.87. That is our first value. And then let's see if we can keep this our second value. Please tell me what is 360 minus this. That is 291.13.
Yes.
Yes.
Yes, so this is within this range. Let's just check if we can have one more value. See what is 360 plus 68. Oh, that is going to be on. This is 420 something, Hannah. So we can't keep that. So these are the values of y. And let's quickly get back the values of theta from here. So your theta is actually going to be y minus 56.31. So you one by one subtract 56.31 from these values of y. So what is the first value of this y? 68.87 minus 56.31. So what is this theta? 11,
12.6.
12 point.
12.6.
Okay. We can write this correct to one decimal place. Okay. And then the next one.
34.8.
234.8. So guys, this is the whole procedure I have explained, that how to first of all convert these two terms into a single term over here, and then how to solve that. Okay, let me do one more question and then you guys will practice it yeah, this is the third question I'll be doing. I don't want to do a harder question because once you yourself try these first 4 or 5 questions, you will be able to handle those questions yourself. Okay, so let's do that. This third question, because it is asking for the greatest value as well over here. So the third question, it says express this 15 sine theta minus 8 cos theta into this. You see, this is starting from the sine term, and you have to write this in terms of sine. And there is a minus over here, and there is a minus over here. So we have no problem while saying, yes, my A is 15 and my B is 8. That's it. Okay. My A is 15, my B is 8. It says give alpha correct to two decimal places. There is no condition on R. So R might be an exact value in this case. So you have to see that what are the conditions for these values over here. Okay. So it says R is positive, alpha is acute. Okay, so you know that your R is the square root of A squared plus B squared. So this R is the square root of 8 squared plus 15 squared. I think that is going to be 17. Hmm?
Yes, yes.
Yeah, this is exactly 17. Okay, good. And then you have alpha. That is your tan inverse of B over A. So alpha is going to be, can you quickly tell me what is tan inverse of 8?
28.07.
Okay, this is 28.07. So this expression that we had here is now going to be 17 sine, and then you have this theta minus 28.07. That's the A part done. Then it says hence solve the equation blah 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 equal to 3. So now we shall be, instead of all of this expression here, instead of all of this, I should be writing here 17 sine theta minus 28.07. Okay, and that is equal to 3. And your theta is between 0 and 360. Okay, we should suppose, if we can't handle this mentally, because at P3 level, students start doing the things, many things mentally, okay? So if you can't do that mentally, you just put that equal to y. So this is 17 sine y, that is equal to 3. So we should tell that what are the limits for the y. This is going to be minus 28.07. What is this? 360 minus 28.07. That is 331.93. Yes?
Yes.
Okay, so now your y, sine y is positive here. So this is going to be in these two quadrants here, Hannah. Yes. What is sine inverse of 3 over 17?
10.16.
Okay, beta. Great. MashaAllah. People are active in the morning. Okay, can my first value be 10.16? Yes.
Yes.
It can be, okay. And then my second value, 180 minus this, that is
169.84.
169.84. Can we have a third value here? No, we can't. This is
No.
beyond 360. So let's get back the values of this theta here. So using this relation, we have this theta equal to y plus 28.07. So this is going to be 38.2, Hannah. And this is going to be 180,
197.9.
yeah, 179.
99.
Okay,
197.9.
okay, 197. This is, come on, yeah. This is what are you saying? 197?
Yes,
Oh,
1
sorry. I was adding 10 into it. This is 68 here. Thank you. 197.9.
9.
Okay. So these are the two values of I mean, these are the two solutions for this equation. You please see this once again, that we are learning all this method because initially in your P1 level, when you had two terms, one is sine, the other is cos, there was always a zero over here. And we could solve this by simply dividing both the sides by cos theta. But you have a number over here now. So to solve this equation, you need to change these two terms into one single term. As we have done here, we have written it as this, okay? And then you can solve this. Now see the third part. It says find the greatest value of 30 sine theta minus 16 cos theta. So see, let me first have some space for this. Yes. Okay. He is asking for the maximum value of 30 sine theta minus 16 cos theta. So we are not kids. Now we know that this is basically 2 into 15 sine theta minus 8 cos theta. Yes, we can use this expression here. Okay? And instead of this, I'll be writing 17 sine blah, blah, blah. So this will become 2 into 17 sine theta minus 28.07. That is 34 sine theta minus 28.07. Okay, it says as theta varies. So you ignore this theta minus 20. Like if theta can be anything, okay, na? So what is going to be the greatest value of all of this, guys? What is going to be the greatest value of sine theta? Hmm? You remember your
Say
sine,
one.
yeah, sine theta is between 1 and minus 1. And the same is the case with the cos theta. So this sine theta minus 28.07 can have a maximum value of 1. Therefore, this 30 sine theta minus 16 cos theta's maximum value is going to be, the maximum value is going to be equal to
34
34. And what would be the minimum value?
minus 34.
That is minus 34. Okay. I can show you this. Sometimes he writes this in the denominator. Let me show you if we have a, yeah, look at this question. Let me erase this. Yeah, look at this. Um, you can like just write cos here. This is not something I wanted to show you. This one over here. It says find the least value of all of this as theta varies. ये भी स्क्वायर डाला हुआ है इसने, वो ज़ाहिर आप स्क्वायर कर दोगे. I just want to have that without a square. Okay, let me make it myself. Now, suppose if the question was that you have to give the maximum or the minimum value of, let me say, let me just write this as 15 sine. You can vary this accordingly. Okay, we have to give the maximum or the minimum values of uh, this whole thing. Okay, so you see that. Just see that this can be, what can be the maximum value of this 15 sine theta minus 8 cos theta? That is this
34.
17. I'm not asking for this one, beta.
Yes, yes.
है ना? That is going to be 17. So one extreme value is going to be 1 over 17. And then this can also be minus 17. है ना? This can also be minus 17. In fact, I have recalled that question. Let me write it. Now the question is, the question says, let me go back to this question. The question would say to you that, okay, where it was, here. The question would say that, yes, find the maximum or the minimum value of, let me write that. He would say, find the, like there would be a question like this, 15 sine theta minus 8 cos theta. Let's say you have plus 10 over here. Okay? He would say, find the maximum value of this. So you would say, okay, let me write it like this, 1 over 17 sine theta minus 28.07. Okay? And then there is a plus 10 over here. Okay, there's a plus 10 over here. So uh, now this is simply if you have, for example, if you have 17 sine blah plus 10, है ना? So its sketch would be something like this. In the first 360 degrees, you will have 10 over here, you will have 27 over here, and you will have minus 7 over here. Yes or no? Please tell me quickly.
Yes.
Anna, remember
Yes.
this was the axis, this was the amplitude. Just ignore the angle wala part because there's no limit on these angles over here. So right now the maximum value is 1 over 27. I mean, this maximum value is 27, and this is the minimum value, which is minus 7. So since it is the reciprocal over here, its extreme values are going to be 1 over 27 and then minus 1 over 7. So which one is the, अच्छा एक second, let me make it because I want to keep that simple. There is 17 and let me keep it 5. Yeah, because I have to tell you something else. Okay, this is going to be 5 and this is going to be, let me cover this, let me make it a bit neat and then I'll discuss this with you. Okay, yes, okay. If this is your equation here, that you have 5 here, okay, instead of 10 you have 5 here. So your x's, oh, it will again, I don't want to have a minus value here. So I think I should keep 20 here. Yes, let me keep 20 here. So you have 20 here as the axis. This is your 37 and this value is going to be 3. Yes, I wanted to have this situation. So this greatest value, which is 37, will now become the least value because this becomes 1 over 37 because of being the reciprocal here. So I have written 20 over here. Okay, and this is 1 over 3. This is what the examiner is going to test over here. See, when this goes in the denominator, so obviously these are the extreme values your whole of this function can have. So this 37 is now going to be 1 over 37 and this 3 is going to be now 1 over 3. So which one is bigger? Which one is bigger, 1 over 37 or
1
1
over 3.
1 over 3? So that is, this is going to be the greatest value of this 1 over blah, 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 blah. Okay. And this is going to be the least value of this 1 over all of this. So guys, that is it from today's this session. I have explained to you how to write the given two terms in sine and cos into one single term, and then how to solve the equations and determine the maximum or the minimum value. Now you have to practice this exercise here, which is this exercise 3E from this P3 book. Okay. Thank you very much.